Greetings everyone. I'm delighted to be speaking with you all today on my work. The topic of my work is particulate matter forecasting using neural networks, a case study of Delhi. The presentation will proceed as follows: introduction, material and methods, results and discussions, and conclusion and references. Introduction. There is a continuous addition of unwanted particles in the environment due to an increase in industrialization and urbanization in metro cities. These unwanted particles contaminate the natural resources and hence lead to environmental pollution. These unwanted particles which lead to environmental pollution are called pollutants. Any physical, chemical or biological agent that disturbs the natural characteristics of atmosphere which causes pollution is termed as air pollution. It is a serious environmental issue that is drawing attention globally. Its various sources include industrial practices, vehicular emission, and farming activities. Effects of air pollution. Air pollutants have an immediate influence on the respiratory system and lead to major illness like respiratory morbidity in children and elderly people. People experience a wide range of health effects from being exposed to air pollution. Effects can be broken down into short-term effect and long-term effect. Short-term effects, which are temporarily, include illness such as pneumonia or bronchitis. They also include discomfort such as irritation to nose, throat, eyes, or skin. Air pollution can also cause headaches, dizziness, and nausea. Long-term effects of air pollution can last for years or for an entire lifetime. They can lead to person's death. Long-term health effects from an air pollution include heart disease, cancer, and respiratory diseases. Air pollution can also cause long-term damage to people's nerves, brain, kidneys, liver, and other organs. People react differently to different types of air pollution. Young children and older adults whose immune systems tend to be weaker are more sensitive to air pollution. Conditions such as asthma, heart disease, and lung diseases can be made worse by exposure of air pollution. The length of exposure, the amount, and the type of pollutants are also factors. Children between the age of 0 to 6 years, senior citizens, and outdoor workers are mostly affected by air pollution. Status of Delhi. In metropolitan cities like Delhi, the Air Quality Index (AQI) changes every season, implying the bad air quality of the state. As per World Health Organization 2018 records, Delhi is one of the most polluted cities in the world. The annual average concentration of PM10 in Delhi at certain places is highest among Asian cities. The smog affects visibility levels to such an extent that Indian Railways cancels or divert several trains passing through Delhi almost every year. Similarly, there are frequent flight cancellation and delays due to poor visibility conditions. The Chief Minister of Delhi compared the city to a gas chamber, stating that this was a common problem every year. The government ordered the closure of schools and educational institutions as remedial measures. There were a tremendous increase in level of patients complaining of acute respiratory problems in the capital. Hotspots. Hotspots are the places or localized areas with high concentration of a pollutant or amount of pollutants much more than background concentration in that region. These hotspots are spread all over Delhi. Delhi as hotspot. Most of the locations in Delhi NCR are highly polluted and some are seasonally based. In winters, entire NCR acts as an air pollution hotspot due to stubble burning firecrackers in neighboring states of Haryana and Punjab. These hotspots are Ashok Vihar, ITU, Anand Vihar, Patpatganj, DU North Campus, RK Puram, Shiri Fort, Wazirpur. These hotspots are taken based on July 2019 AQI and PM10 readings at these places as given by Central Pollution Control Board CPCB. Materials and methods. The methodology followed for the study is presented as data preprocessing, data normalization, prediction of PM10 using artificial neural networks ANN, sensitivity analysis. The different hotspot sites selected for study is R.K. Puram, Anand Vihar, Ashok Vihar, Patpatganj. The locations of these selected hotspots are shown on the map of Delhi. The dataset. The dataset consists of pollution concentration and meteorological parameters for selected study areas. The PM10 concentration and meteorological parameters, that is, wind speed, wind direction, solar radiation, relative humidity, atmospheric temperature, barometric pressure were collected from Central Pollution Control Board CPCB website for the duration of 4 years. Data preprocessing. The obtained data contained some missing values, so interpolation of data was done. Data normalization. The normalization of data was done using the following equation. The different neural networks used for prediction of PM10 concentrations were feed-forward backpropagation (FFBP) element neural networks, recurrent neural network (RNN), nonlinear autoregressive exogenous model (NARCs). Sensitivity analysis. For comparing the results obtained through various neural networks, sensitivity analysis was done on the basis of R and MSC values. Correlation coefficient R. Correlation is a statistic association. It refers to how a pair of variables is linearly related. Correlation coefficient was calculated by the given equation. Mean square error. The MSE measures the average of squares of the error. The equation used for calculation of MSE is as follows. Results and discussions. All neural networks, namely FFPP, LMN, RNN, NUGs, were run for different number of hidden layers for the selected hotspots. Then, the layers at which best results was obtained was selected as final results. The results for each neural network at each hotspot are given. The table shows the MSE and R values of selected hotspot for different neural networks. The best value of R and MSE is obtained for Anand Vihar station, that is 0.91 and 0.002 respectively for NUCs. The feed-forward backpropagation (FFPP) performance was poor as compared to other networks for all the sites. The performance of FFPP was a bit low because FFPP are extremely sensitive to architecture and number of parameters chosen. Conclusion. With rising of air pollution, there is an immediate need to develop an accurate prediction model which will work as early warning systems to safeguard public health. The various neural networks were run using meteorological parameters as input data and pollutant concentration such as PM10 as target data. The prediction models with their accurate prediction can work as early warning systems for the government. These prediction models can help the government to either reform or to form necessary policies for improving the air quality over a particular region. These models can help to create awareness among residents of the region towards the deteriorating air quality. That concludes my presentation, and I would like to thank you all for your time and attention today. I sincerely appreciate that I have had this opportunity to present to you. Thank you all for being here today and taking time to patiently listen to what I had to say. I wish you all a very good day. The following are the research papers I used as references for my work. Thanking you all again for your time and attention.